Okay, we go now to chapter 4, Principles of Generator Action. We have here Paradise Law. In Paradise Law, the magnitude of the generated voltage is directly proportional to the rate at which a conductor cuts magnetic lines of force. Paradise Law implies simply the higher voltage by moving conductors move more rapidly across lines of flux. By increasing the number of flux lines across which the conductor moves, or by increasing both the speed of the conductor and the flux across which they move. So dito sa Paradise Law, yung laki daw ng bultaheng nabuo ay direktang proportional daw dun sa pagbabago na kung saan ang isang conductor ay pumuputol ng magnetic lines of force. So, ang ipinaliliwanag ni Faraday, yung batas ni Faraday o ang ini-imply nito ay kapag mataas yung mga voltahe sa pamamagitan ng paggalaw ng mga conductors ng mas mabilis sa kalagitnaan ng mga lines o linya ng mga flux at sa pamamagitan ng pagdaragdag ng dami ng mga linya ng mga flux sa kalagitnaan na kung saan ang conductor ay gumagalaw or sa pamamagitan ng pagdaragdag ng bilis at ng conductor, mga conductor at ang flux na kung saan sila ay gumagalaw, lumalaki o nakakabuo ng generated voltage sa pamamagitan nun. Sinasabi dito na natuklasan daw na kapag ang isang conductor ay gumagalaw sa isang parehas, no? O hindi nagbabagong bilis sa kalagitnaan ng pare-pareho at makapal na magnetic field. Yun yung mga field na kung saan yung flux density niya sa mga linya ng puwersa per square inch o kada square inch sa isang constant o pare-pareho, natuklasan nila na ang 1 volt ay nabubuo sa kada 10 to the 8 lines na napinuputol kada segundo o tinatawag ito na Maxwell. Class, meron tayong general formula para dyan. Ito yun. Yung average voltage o yung voltage is equal to the flux, no? The total number of flux divided by yung time multiplied by 10 times 10 to the 8. So, yung E-average, yun yung average ng generated voltage sa conductor. Yung P, sa Greek letter P is yung total flux cut. Yung T, yun yung time na kung saan yung segundo kada pagpuputol niya ay nangyayari, no? So, take note, ang 1 Weber is equal to 10 to the 8 Maxwells. Ang isang linya ay nagtataglay ng isang Maxwell. Ang isang ikot ay nagtataglay ng 2 inductors. At lagi ka mag-a-assume ng 12 ikot kada coil kung hindi given. So, ito yung mga terms na dapat yung tandaan, no? Inductors per path, inductors per slot, coils per slot, turns per coil, inductors per turn, flux per pole. Throughout the computation, may encounter nyo itong mga terms na to. So, dito na tayo sa example, no? A 4-pole DC generator has an armature winding containing a total of 648 conductors connected in two parallel paths. If the flux per pole is 0.321 times 10 to the 6 Maxwells, and the speed of rotation of the armature is 1,800 RPM, calculate the average and total generated voltage. My class, we have the following given, no? Sulat muna natin yung given. Taas ko lang ng konti ito para medyo we have the given. Gamit tayo ng kulay blue. We have the number of poles is equal to 4. The inductors is equal to 648. We have 648 inductors. Then we have the flux per pole, which is equal to 0.321 times 10 to the 6 Maxwells. Ang speed niya ay 1,800 RPM. Ang number of parallel paths ay 2. Ang required yung average, no? Average voltage. Average. So, i-average. Taas ko lang is equal to the flux divided by in time times 10 to the 8. So therefore the flux is equal to parang magko-convert tayo, no? You have 4 poles. Multiplied by, kasi yung kaninang given ay flux per pole yun. Yung total number of poles. So, one pole is equal to, sa given nakalagay ay 0.321 times 10 to the 6 Maxwells. Lakayan lang natin itong linya. So therefore, the flux, the total flux is given by 1.284 times 10 to the 6 Maxwells. So yung speed naman, kunin natin yung speed in revolution per second. So to get the speed in revolution per second, we have the speed equal to, dito na tayo magsulat. We have the speed equal to 1,800 revolution per minutes, no? Times 1 minute is equal to 60 seconds. So therefore, yung speed is equal to 30 revolution per second. So revolution per path ngayon kunin natin, no? Yung revolution per path, inductors per path pala, sorry. Yung inductors per path is equal to 648 inductors divided by 2. Kasi dalawa yung number ng parallel path as given, no? So therefore, the inductors per path is equal to 324 inductors per path. So kailangan natin ma-solve yung time, no? So we know that we have a speed given as 30 revolution per second. So therefore, let us solve for the revolution, no? Solving for the revolution, this is actually the speed, no? So solve natin yung revolution. So 30 revolution is equal to the speed multiplied by the time. Ano yung time? Yun yung seconds, no? Then, let us solve for the time. So the time is 30 revolution divided by the speed. So 30 revolution divided by the speed. So 1 revolution, therefore, yung speed natin is given as 30 revolution divided by Ang speed natin ay 30 revolution per second. Or revolution per second. Bali 1. 1 revolution per second is 30 revolution, no? Magka-cancel ngayon itong revolution. Magka-cancel ngayon yung revolution, no? So time is equal to akit yung seconds sa taas. 30 seconds. Magka-cancel kasi yung revolution, no? So therefore, the time is equal to 30 seconds, no? Or 1 over t is equals to 1 over 30 seconds. Yung 1 revolution is equal to speed multiplied by the seconds divided by 30. So, pwede mo i-multiply, no? Speed multiplied by 1 over 30 seconds. So, naka-multiply ito, ha? So, where yung speed ito rin yung tinatayong velocity niya, no? At yung t, yung time. In seconds, no? Ito, time in seconds yan. So, substitute na natin siya ngayon, no? So, substitute to the general formula. So we have E average is equal to the total flux, no? Divided by the time times 10 to the 8. So therefore, you have 1.284 times 10 to the 6 Maxwell's divided by the time, 1/30 seconds. Times 10 to the 8, no? So therefore, calculating, you have E average equal to 0.3852 volts per conductor. So may note tayo rito. Note. Ang 1 Weber is equal to 10 to the 8 Maxwell's. So pag sinabing lines, Maxwell's din ang ibig sabihin nun, no? So one line is equal also to 1 Maxwell's. Here in example 2, so sa example 1 daw, calculate natin yung generated voltage. Kasi yung sinolve natin sa example 1 ay average voltage lang, no? So, solution na kagad kasi yung given naman ay nandun sa example 1. Okay? So, we have the solution. Usod muna natin ng konti. So, we write now the solution, no? So, ito ngayon yung solution. So, dito sa solution, we have the generated voltage is equal to 0.3852 volts per inductor multiplied by 324 inductors per path. So therefore, the generated voltage will be equal to 124.8048 volts. Okay, yan yun, no? Let's go now to the next example. Calculate the average voltage in a moving conductor if it cuts 2.5 times 10 to the 6 Maxwells in 1/40 seconds in 1/80 seconds. Okay. So here now is the given for example number 3. So we have the flux, which is equal to 2.5 times 10 to the 6 Maxwells time is equal to 1/40 seconds and 1/80 seconds. So required in average voltage, you know. We go now to the solution. The average is equal to the flux divided by the time multiplied by 10 to the 8. So which is equal to 2.5 times 10 to the 6 Maxwells divided by 1/40. Yung time kasi 1/40 seconds times 10 to the 8. So therefore, the average is equal to 1 volt. Okay. Then we have now at T is equal to 1/80 seconds. So E-average is equal to 2.5 times 10 to the 6 Maxwell's divided by 1/80. 1/80 seconds multiplied by 10 to the 8. So therefore, E-average is equal to 2 volts. Okay, we go now to example 4. In example 4, it is written that in example 1, calculate the rated current in each conductor per path if the power delivered by the armature is 5 kilowatt. Okay, let's go now to example number 4. Solution na kagad tayo, no? We write the solution. Kasi yung mga given naman ito, ay ibigay na dun sa example number 1. Kaya solution na lang ilalagay natin. So based from example number 1, what is being asked is the current, no? Calculate the rated current in each conductor per path if the power delivered by the armature is 5 kilowatt. So from our solution, we have I rated. I rated is equal to the power is given is equal to the power delivered by the armature divided by the generated voltage. So 5 times 10 to the 3 watts divided by 124.805 volts. Therefore, the I rated is equal to or the rated current is equal to 40.062 amperes. This is for example 4. We go now to general voltage equation for direct current generators. Or we consider this as EMF induced in armature winding. This is our general formula for induced EMF or generated voltage. And this is an animated sample of a generator. So it is a single armature conductor cutting flux of 4-pole dynamos. Okay, consider nyo itong figure na ito, no? Kung saan yung generator, umikot yung armature ng consider ninyo na umikot from center to center kasi yan eh. No, consider nyo ito. Simula dito sa gitna nito hanggang sa gitna nito, no, iikot yan ng ganito, no? Ganyan. Yan, iikot ng paganyan at nakabuo siya na simula rito sa gitna nito hanggang dito, nagkaroon siya ng tinatawag na differential time. Yan, nagkaroon siya ng differential time. So ano ibig sabihin ng differential time na to, no? Ganito ngayon ang mangyayari, no? So the time differential niya, taas ko lang ng konti. The time differential will be given like this, no? So, magiging 1 pole span. Ayan yung tinravel niya eh, simula rito hanggang dito eh. Times the speed, no? So, ibig sabihin, ang unit nito ngayon ay revolution, no? Ito. Naka-revolution yan. Bakit revolution? Kasi umikot siya simula rito sa gitnang ito hanggang papunta rito. So therefore, change in time equal to 1 over P or the pole span, no? In revolution. Times 1 over ang unit nitong speed ay revolution per minute. Yan, revolution per minute. So, ang gagawin dyan was revolution per poles. Kasi dumaan siya sa dalawang magnet poles or umikot siya simula dun sa unang pole hanggang sa pangalawang pole, no? Times mathematically evaluating magiging minutes per revolution. Cancelin natin, no? So, magiging result, minutes per pole. So, convert natin sa second. 1 minute is 60 seconds. Times yung speed na ito, no? Hindi natin na idagdag. Dapat nandito to eh. So, magka-cancel tayo. Equals 60 over P times N or the number of poles times the speed. Ito ngayon yung formula ng differential time or change in time. So let us consider this as equation 2. Kasi ang equation 1 natin ay yung general formula. Substitute ngayon natin yan sa equation 1, no? Substitute. Equation 2 to equation 1. So we have equation 1 as E or E generated. equal to the number of turns multiplied by the change in flux divided by the change in time times 10 to the negative 8. Naka-volts yan. Saan natin siya pwede ipasok? Dito sa numerator, no? So we have the number of turns. Substitute natin dito yung formula, no? Multiplied by 60 over the number of poles times the speed divided by the change in time times 10 to the negative 8 volts. Yan. So let us fix the equation, no? O let us evaluate further. So magiging n multiplied by may correction class sa baba pala dapat ito. Dito mo siya dito yung change in flux. Tapos yung change in time, lalagay mo rito na 60 over the number of poles multiplied by the speed. So therefore, evaluate further, we have change in flux. Bakit itong number of poles times the speed, no? Dito. Divided by 60. Times 10 to the negative 8 volts. But the number of turns is equal to the number of inductors divided by the number of parallel paths. So pwede natin i-substitute. Tawagin natin itong equation 3. Or ito ang equation 3. So ito ang equation 4. So substitute equation 4 to equation 3. So we have the generated voltage equal to, so instead na isulat mo tong number of turns na n, pwede mo siyang isulat na inductors per path divided by inductors per path niya. Tapos multiplied by the change in flux times the number of poles times the speed over 60. Then, may condition, no? Let the change in flux equal to the flux itself, no? So therefore, you can write generated voltage equal to the number of inductors times the number of flux times the number of poles divided by this, multiplied by the speed divided by 60 times the number of parallel paths. Ito yung pinaka-formula ng generated voltage. No? Okay, this is now our formula. And this is the formula for the generated voltage or total generated voltage in volts. We have the Greek letter P, which means flux per pole in Weber. We have letter P, number of poles. Also, we have small letter N, which stands for the speed of armature in RPM or revolution per minute. And small letter A, number of parallel paths determined by the type of armature winding. May note dito, no? If the Greek letter P is in Maxwell, or if the flux has a unit of Maxwell, you multiply this equation, ito, no, this equation, itong equation na to, sa times 10 to the negative 8.